This video will show you how to do descriptive statistics with R. Descriptive statistics is where you're going to try to find the mean, the median, or whatever you happen to want to find. In this, you're always going to use the GF underscore stats. We use GF underscore stats because we're using, again, the Mosaic package. Notice I have Mosaic. Going to be started here. I'm going to go ahead and run my setup to get my variables. All right. So I'm going to use the Mosaic package. Again, it's always GF underscore stats to do your descriptive statistics. Then you're always going to start with your tilde, your response variable, your explanatory variable. There is no response variable at the moment. There can be. We'll put that in later. And then your data set equals your data, what data equals data set, and then whatever statistics you're interested in finding. So I'm going to type in mean if I want the mean, median if I want the median, SD if I want standard deviation, var for the variance, range gives you the range, summary gives you the 5-number summary. You can actually put these all together in one line or whatever ones you want in a line, and it'll give you them all at the same time. So if I'm using the data set cancer, again, I'm going to use, instead of the head command, I'm going to go ahead and use the glimpse command so I can see what this one looks like. And there are 64 rows, 2 columns, survival, and organ. I'd like to find the mean, so I would do df underscore stats, and then tilde survival, data equals cancer, and I want the mean. And there's my mean. To find the range, I replace the word mean with range. The range gives you your lowest and upper. If you actually want to know that subtraction of that, you would just subtract these two numbers. You can actually do that in R. You can actually insert an R chunk. So we'll insert an R chunk. And then we would do 3808 minus 20. And you actually, by the way, can copy these if you want. And then you can just run that and it'll calculate that for you. You can find the standard deviation by replacing range with standard SD for standard deviation. Run that again. Variance would be var. And summary will give you the 5-number summary. But summary actually gives you a little bit more than the 5-number summary. It gives you your minimum, your first quartile, your median. It does give you your mean, and then your third quartile and your max. Again, you can do these at several at a time, and it'll give you your response, your mean, your median, and your standard deviation, because that's all I asked for. A box plot, same idea. It is a graph, so it's GF for graph function, box plot. You will have your response variable, tilde your explanatory variable, but in most cases you only will have a explanatory variable. Still start with the tilde, whatever title you want it to be. And then you do need, and I don't know why I don't have this here, you do your data equals data set. And I can run this. And this gives me this type of axis. And you can change your axis. You don't want this to say survival. You want it to say something more about this. You can actually do that. This is the x-axis, so you call it xlab to change that. All right, if you want to facet, again, faceting means you're dividing it up based on some categorical variable called faceting. And you would do your quantitative variable, tilde your categorical variable, and your data equals data set and your mean. This allows you to facet it based up on. So if you want to find the mean, median, and standard deviation of survival times for different types of cancer, you would do df underscore stats, survival, tilde, organ. So survival is my quantitative variable, tilde, organ is my categorical variable. Data equals cancer, I want the mean and the standard deviation. I can run that one just by itself. And there it gives me my survival, my different organs, and my mean and standard deviation for those. So you can see kind of what's going on. and what happens with these. You can see mean for breast density seems to be much higher, though it does have a fairly high standard deviation. So there's a lot more spread in that one. I can also do the box plot. Faceted by that. Box plots are much better with faceted data. A single box plot doesn't give you much information, but here you can compare them much easier. This is known as a modified box plot because these are your outliers. Whenever you have these dots by themselves, you can see you have outliers. You can see there's no lower outliers, there's just higher outliers. If you want to run the whole thing together, you can just hit the green arrow, and that will do both at the same time, and you can then click between them to access them. A weighted average, to find a weighted average, you use weighted average, weighted.mean of x comma p, or whatever x and p are, where they're going to be, you're not doing a data set here, you're doing kind of a variables. So let's say you suppose you score 95 on a homework that is worth 50% of your grade, 83 on test 1 with 25% of your grades, 76 on test 2 with 25%, and 84 on the final exam worth 35%. What grade do you have in the class? First, you're going to summarize the information in a table. That's very helpful to do that so you can see how things relate to each other. So you can see your pairs because you need to put them in these pairs. Notice the weight does in fact add up to 1. There are 225 because there's 2 assignments that have the same weight. And you're going to put the data in. So you're going to type in grades. You can call them anything you want. I call them grade. You're then going to assign. So remember this lesson symbol and dash means you're going to assign to there. C means combine these into one term. So we're going to, grade is going to be assigned to be the combination of 95, 83, 76, and 84. So I just took this first column. Weights is going to be assigned to a combination. And notice these numbers are in the same order. Don't mess up the order. And then I do a weighted.mean grade, weights. And there's my grade. And there's my weighted average. And that's it.